Hey guys, welcome to DevOpsSchool. In this video tutorial, we are going to learn about Kubernetes. Kubernetes is developed by Google and it is an open source platform that automates container operations. It eliminates many of the manual processes involved in deploying and scaling containerized applications. After going through this tutorial, I promise you that the concept and understanding of the Kubernetes will be absolutely clear to you. But before we begin, let me inform you a few things about us. DevOpsSchool is one of the leading platforms which offers DevOps, cloud and containers technology training and certification programs for freshers and established professionals who wish to update and consolidate their skills in the dynamic IT scenario. We ensure that the training solutions are delivered by highly experienced domain experts with practical working experience in various verticals. You can join our all training programs globally through online platforms, and if you're looking for classroom workshop, then we have regular batches available in Hyderabad and Bangalore. Check out the dates and enroll with us for our upcoming batches. For more info, link and contact details are mentioned in the description below.
Okay guys, so far we have discussed so many things. We have discussed what is Kubernetes, then we discuss why Kubernetes, then we discuss how Kubernetes works, architecture, master, node, workstation, desired, declarative, all these things we have understood. Now we need, and pods also we understand, replication controller also we understand, deployment also we little bit of things we discussed. So many things we discuss here, and then most important thing which is pending right now, how can you access pods? And then if you remember the problem which we have shared, like pods is running across the multiple nodes, same kind of pod. So how these pods can be internally or externally accessible, and that is where we need service. Now what is service, we need to understand. So let's get started, and let me tell you guys that this is the most important session. So understanding the service is very much important. So I would request everyone to focus on this discussion, because during the demo and lab I won't get again slides and then scenarios of explanations and stuff like that. So you have to recall those stuff during the demo, so that way others will get compromised with the other agenda also. So please focus on this. So what is services? So now look at this image here. So here you have 6 node. Look at this 6 node, node 1 to 6. Now if you look at this, node has a pod. Now you understand the pod, and if you look at this, inside the pod you have a container. Okay, each pod you get you see that there's IP address, right? And if you also a little bit concentrate inside the container label, I mean text, some containers belongs to the front end and some containers belongs to the DB. Okay, you also notice here because of the actual state and desired state, if it is mismatched, then I have stated like containers getting replaced. So the moment new pods get replaced. So when pods get replaced, the new pods get a new IP address. So these are the challenges. So these are the scenarios which you have in the real-time infrastructure when you're using Kubernetes to run your application. So yes, 6 node. Each node has a few pods. Each pod has a container. Some containers belong to the front end, some containers belong to the back end, DB. Pods get replaced, new IP address comes, and stuff like that. And the question is, which front end will talk to which back end? That is the question. Because you have a front end running in the different nodes, back end running in the different nodes. Which front end will talk to which back end? Because there are 2 back ends, 4 front end. Now next problem is, when you scale, then IP address of the pods get changed. So you see that you had a 2 pod of the backend, now we have a 3 pod of the backend. See, you have the 2 pod of the backend. Now you have a 3 pod of the backend. IP address get changed. You upgrade is a one more problem. Earlier the backend, the version was V1. With upgrade, you got a V2. So here, if you see that, see the problem. You wanted to have a 3 pod, 2 pod. Now you wanted to have a 3 pod. So 2 pod got version 2, 1 pod still got version 1. So this is the problem. So how this front end will talk to the back end, and which backend they will talk, because not only you have a multiple backend, but also the versions are different. Also the problem here is like scaling the IP address is getting changed. So how can you solve these problems? Okay. Are you able to understand these problems in a Kubernetes? Are you able to understand these problems? Guys, are you there? Can you hear me?
Yeah.
So this is the problem. This is a genuine problem which you have. So now, how can you get rid of the old ports also? Because all the traffic should go to the new ports. See, how to fix this problem? And the solution for all problems, which we discussed last 5 minutes before the lunch also sometime, is service. Service is a solution for all problems. So now service is a kind of load balancer, you can say. And service IP address never change. Service IP address. So service is one of the object which has a properties to load balance a pod. Yes, you have studied, we have discussed pod, replication controller, deployment. Now service is one of the object which you desire, declare in a YAML file, declared in YAML file, and service has a certain properties, and the property is one of the most important property is it has the ability to manage and load balance a pod. The moment you create a service get IP address and DNS, which never get changed. And now the problem can be solved out. So if you see that here, all the front end will talk to the service. The service will redirect the communication to pod. Okay, pod. So the answer of this problem, solution for the problem which we had earlier is service. Now, if you add a more pod, new IP address get added, and the service automatically detect these new pods. How? I need to talk about it. But service automatically detect these new pods. So earlier you had a 2 pod hitting to the same service. Now you have a 4 pod hitting to the same service. Now automatically this happens. Automatically this gets resolved. So how it get resolved, I need to discuss this, but for time being, let's solve the problem. So service is a kind of load balancers in Kubernetes world. And using the service, you can access the similar nature of the pod, and service will help you. So here front end of the service will redirect the traffic to one of the pod, and service always redirect to the traffic to the healthy pod. Healthy pod means the pod is healthy because of it's running because of the container is running, and container is running because of PID1 is running. PID1 is running because of the images is stable. So that is the one. Now next problem. Now here if you look at this, all the front end is talking to the service. But service has a problem. The service has a 2 pod which is with the V1 and 2 pod which is with the V1.2. In a simple way, if I put it, if you log into your database, log into your Gmail, sometime you see today, just now I logged in and I see 50 emails, and just after 2 minutes you log in, you see 100 emails. Will you accept this behavior? Of course not, because you want one service similar line of application, same version of applications which you want. Don't want like v1, v2. So service is a solution for the problem for the load balancing, accessing the pod. The pod should be done similar line, but here is a problem. I have a two different kind of pod hitting to the same service. So sometime the front end will redirect the traffic to the v1. Sometime the same traffic will be redirected to the v2. That is a problem. So how can you solve it? That is where label rocks. Yes, label rocks. It's the same labels which you have heard about a lot, so many times in a different terminologies. Sometimes you call it labels, sometimes you call it tagging, sometimes you call it giving aliases or whatever it is. In Kubernetes, we call it label. That means whatever you create, label it. I'm not saying name it. I'm saying label it, because labels can be duplicated. Names cannot be duplicated. Remember, labels, same labels you can assign to the multiple pods. Same name you cannot assign to the multiple pods. So here, label rocks. How label works? Let's understand this. Here you see anything you create, and this is your work. This is the work which you have been, which you'll have to do, and this is the work which you have been hired for, because everything will be done by the Kubernetes. What you're supposed to do, you're supposed to desire and declare in the YAML file. Now, desire, how to express your desire in YAML file, that is what I'm trying to help you to understand. You have to desire for pod. You have to desire for the application controller. You have to desire for the deployment. And now, if you want to access the pod for the internal and external purposes, you have to desire for the service. The question is, service will load balance the pod, but sometimes by mistake, service can be load balance the wrong pod also if you attach. How can you correct this mistake? So if you look at this image here, labels will help you to classify the right pod to the right service. Again, I'm saying labels will help you to classify the right pod for the right service and load balancing the right pods to the service. How it works? Look at this. Whatever you create a pod, you create a replication controller, you create a deployment. Remember, the replication controller and deployment had the additional feature. You want one pod, you create a pod. But if you want to have a 3-pod, you have a replication controller. But if you want to have a 3-pod plus versioning rollback capability, you do the deployment. Deployment is the one which is under the production right now. So yes, so service is in a way in which you can redirect the pod, but how to redirect only the right pod? That is the most important question, and that's where I say label rocks. So here you have a service named with, I'm sorry, not named with. Again, I'm saying it's not named with, it's labeled with. Service labeled with prod B 1.3. Again, you have a pod DB with the 113 IP address. You have a label with the prod B1.3. Again, another pod B1.3, and another pod B1.3. But here, if you look at this very carefully, 3 pod out of which 1 pod is a wrong pod. So sometimes the service is redirected into the pod which is of the DB, but sometimes because of the wrong labeling is done, service is redirecting the communication to authorizations, which is the wrong pod. It's not matching. Labels are matching, but the functionality you get different. So sometimes if I put it in this way, if you log into your Gmail, you get a Gmail, but sometimes you log into the Gmail and you get a login page. See that how it happens. Do you accept this behavior? Of course not. So how can you solve the problem? How can you solve the problem through the right labeling? So what you have to do, you have to label it, each pod, each object in Kubernetes very, very careful. You label it wrong, you get a wrong results. You label it right, you get the right results. So label always rocks and in the Kubernetes and service. So let me tell you here label of pod, again please read my line. Label of the pod should match with the service. Again, I'm repeating, label of the pod should match with the labels of the service. Automatically service will load balance. Label of the pod should match with the service. Automatically service will load balance. If the label of the pods is not matching with the service don't know that pod. Very simple statement. I hope that is clear. So now look at this image, the problem which you have. Now we have a service and we have removed one of the label, prod B, and earlier it was 1.3, which we have removed. The moment you see the prod B 1.3 is removed, suddenly the service is load balancing the pod 1.3 and 1.4, because I said label of the pod should match with the service. So here label of the pod is prod B matching with the service as well, load balancing. But the problem here is you have a some pod which is with the 1.4 and some pod which is the 1.3. So 1.3 is the older version, 1.4 is a latest version. So how can you solve the problem? Relabel the service. 1.3 relabel with the service, and here now because of the relabeled prod B 1.4, now service is redirecting all of your traffic to the right label. So remember how this load balancer works, how the service works. Service works on the label. The label of the pod should match with the service. Load balancing automatically happens. If it's not matching, not happens. You can do the right labeling, you can do the wrong labeling. We have discussed what is the impact of the right labeling and wrong labeling. Now the question is how this label matches and automatically load balances started working. Services started working. That is where there's one component which is called DNS or DNS, Discovery Services. So I'm going to discuss about the Discovery Services in a little bit of time span, but I'm not giving it too much of jargon to begin with so you get lost. So yes, there's a one component, very important component which we have in the master running, and that is called Discovery Services, which manages the service endpoints. That means which manage the which pod whenever you hit the service, which pod it gets redirected to. So this is the something which you have it. So yes guys, what is a service? So yes, service is the load balancer. It only send the traffic to the healthy pods, can be configured for the session affinity, can point to the outside of the cluster as well. It is a random load balancing, and it uses, just like other load balancer, it uses the TCP protocol by default. Okay, so am I clear with the services? Any questions, any doubts? Any questions, any doubts?
Sir, earlier to this, when you started the pod, whenever the pod it has been assigned an IP, it will be constant for all the pod, whatever the container would be there inside a pod, right?
Right, yes. Pod,
Okay.
I said
now
pod, each pod you create, it gets IP address. If the pods get replaced, same IP address will never get assigned. It will get a new IP address.
Okay. So can you just let me know when is a scenario that it can be replaced? A scenario, just a scenario to understand, because
Replaced means something like this. Let's say, put it in this way. Today you have your Deloitte X1.1 software, and you have a 5 pod. But tomorrow, what you want 1.2 software with the same 5 pods. So what you have to do? You have to redeploy with the deployments. So you get a 5 pod of the older pod, 5 pod of the new pod. Now older pod need to be cleaned it up. New pod has to be alive. They will get IP address, new IP address. Now how this load balancing will work? You have to label it pods and services accordingly. So this is how it works.
Okay. So it will not be deleted. You meant to say yesterday whatever the deployment happened would not be deleted. On top of that, the new pod would enhance the new IP address for the new pods. So am I correct?
Yes, always new pods.
Okay.
So Rajesh, labeling will work at pod level, right?
Labeling will work at the every object you can label it, no matter whether you create a pod, no matter whether you create a replication controller, deployment service, anything which you create, labels will be enabled.
For a container,
You can label it. You can label it.
Okay.
Any other questions, guys? Okay. Now deployment. This is the one which we do nowadays a lot, and you also do the deployments a lot. So now let's get started. So deployment. What is deployment? So here, this is the desire which you have to learn how to express your desire, what you want. So yes, if you want the pod, kind will become a pod. If you want to multiple pod, kind will become a replication controller. Okay, in which you see replicas 4. That means you want the 4 pod. If you want one pod, you use the kind pod, no replicas. But here, if you want multiple pod, you can create a replica set. And replica set desire and actual will be controlled by replication controller. So here you wanted replicas of 4 and kind is equal to replication controller. So at any given point of the time, this 4 pod will be maintained. If the one pod, one node goes down, automatically controller will replace the new with the new pod. That's the power of replication controller. Replaced. See, deployment. I said deployment has a feature which is called replication controller 2. So deployment has a feature of the replication controller 2, which is called RC version 2. But along with it, so many other features which we have. Deployment can be versioned. Okay, deployment has a feature of simple rolling updates and rollbacks. Simple rolling update and rollback. Okay, and all this stuff. So now time has come when we should give the piece for our discussion. And if I do the more discussions, I think the things will be based on the only discussions, not will not get less time on the demo and lab. So again, we'll come back to the discussion tomorrow because a lot of the discussion has to happen. I need to explain you lots of conceptual things. Let me tell you here, the commands are damn simple. If you understand the concept, all the commands are damn simple here. So all these things is there. So here you have a, let's summarize the discussion here. So we discuss Kubernetes cluster, master, node stuff, how master manages the nodes. Multiple masters can be possible. HA master has a 4 important component: cluster store, API server, scheduler, and all this stuff. Node has a kubelet, container engine, kube proxy. Then we understand these are the desire which you are going to put it in YAML or JSON objects in the key APIs like a pod, application controller, deployment of services, plus many more objects which we have, more than 50 objects which we have. Again, we'll get into that slowly and stuff like that. So any questions, guys? Anyone have it before getting into the discussion of installing the Kubernetes? Any questions? Any question? So, am I audible?
Yeah, Rajesh.
Yeah, good. So now we'll come back to the discussion tomorrow again. We have few topics to be discussed, but now we have to get into the installing and configuring the Kubernetes. So now we have to decide on which platform you would like to install a Kubernetes cluster. Okay, so you have to decide whether you want the Kubernetes cluster to be created on the cloud or on premises. You have to decide for the cloud you want to set up a Kubernetes cluster based on the infrastructure as a service like a virtual machines, or platform as a service like a managed service, or you want to set up a Kubernetes cluster on a bare metals, or you want to set up a Kubernetes server on the virtual machine on inside the on premises. It's up to you to choose. Now let me tell you here, there are more than 40 different solutions to set up a Kubernetes cluster at different platforms. Let me give you a glimpse of it. If you go to this URL, and you see here, the URL has a 404 status. That means the page has been removed. So probably they might have done the documentations changes. So I click on the Kubernetes documents, and here if I go into the setup a cluster. Okay, set up a cluster. And if you look at this, if you want to understand the basics here, what is Kubernetes, what are the components of the Kubernetes, all these things we have discussed already, and some of the API objects also we have discussed, like a pods, replication controllers, deployment services, and stuff like that. Okay, these are the things. Again, pod we understand now. Other components, objects, few of the objects we have also already tried out. So these are the things which we have done it just now. Now, type Kubernetes, so Minikube and stuff like that, I'm going to discuss it sometime. But here, set up a cluster, and if you see that here, set up cluster, if I click here, again you have a KubeADM, running new environment, production environment, and all stuff like that. But I click on the setup Kubernetes, and here in this page, you see this page. I just update my URL also. Lots of changes is happening every time. So here, look at this. You want to set up a Kubernetes for the learning environment or production environment. You have to decide. If you want to set up a Kubernetes for the learning environment, then Minikube is one of the best tool which you can have it. If you are trying to set up a Kubernetes cluster for the production environment, then hundreds of solutions are there. Trust me here. You can look at this. Hundreds of solutions are start from here. Look at this. More than 30 solutions you can find in this page. Now, which one we are going for it? So basically we are going for Amazon EKS. This is the platform as a service over the cloud. So yes, we are not at all installing the Kubernetes cluster manually. So you can do that using KubeADM, which is somewhere downside. and let me search Kubernetes. It's not there in this page, but if you go back, here it is. See here. Install the Kubernetes setup tool. So you can set up a cluster manually using Kubernetes as well. Let me tell you, those who are planning to prepare for the CKS certification, Kubernetes certification, they will ask you Kubernetes. But as part of the scoping of the discussions, we are going to use EKS, which is the Amazon Platform as a Service. That means Amazon will manage our Kubernetes cluster, not we. Amazon will manage Kubernetes cluster. That means Amazon will manage HA of master. Amazon will manage master. Amazon will manage the availability of the master all the time. We don't have to do anything. We just need to have the desired file. So they will take care of the everything. We need to take care of the desired file, like a pod, replication controller, deployment services, and so on. Now, with this, again, if you look at this other solutions, a lot of solutions which you have, get going. So, do you have any questions on this, like how to set up a Kubernetes cluster? Any questions?
Sir, when you say that you are selecting that AWS EKS for this training, so there are other modes as well as. So when are we going to use those modes? Now it is in AWS, we have an source where we can use it. For other than EKS, how can we do it? So are we going to cover those as well as?
Sorry, I got confused with your questions. Would you mind if you can repeat this question?
So right now there are so many options, right? Managed,
Yes, yes.
turkey cloud, on-prem, data center. So right now you're
Right.
going with Amazon EKS, which is
That's
already
correct.
filled
Yes.
with Docker, everything. So directly we can do it. The second
Right.
thing, if at all we don't want to use Amazon EKS, so in
Yes.
that case, which one do you suggest us?
Okay. So, see, my suggestion is depending on the platform which you are using. Let me tell you, if you are using Amazon platform, EKS is the one of the best. If you are using Google, GK is the one of the best. If you are using Azure, AK is the one of the best. But if you wants to manage, if you have an IT team, admin team of the Kubernetes, and you want guys to want to have a control over the master and masters, HA, backup, restore, security, everything, then you can set it up manually using kubeadm also. There is one more tool which is very popular, COPS, KOPS, COPS, which is also very popular to set up a cluster on the cloud platform. So it's up to you which one you go for. That is also it depends on the platform. But with all this saying, again I repeat, if you are going for the certification, kubeadm is the one which will be used for setting up the production grade cluster, and that will be asked kubeadm. But unfortunately, I am not covering kubeadm, and reason is very simple. Because of this scoping call for this particular program, I have been asked only to cover AWS and EKS. Okay, so that's one of the reason which we are having EKS. But yes, you are free to do any option whichever available here. You can see and you can set it up. Ultimately, you get everything same, no matter which platform you follow or no matter which method you go with. You get ultimately the same master, same nodes, same way. Whatever we discuss is going to work out. Is that answer your question?
Yes.
Yeah. Any other questions, guys? Okay, so now, yes, let's finish this discussion of the installing the Kubernetes. So yeah, now, so yes, you decide where you would like to install cloud, on premises, IaaS, PaaS, what exactly bare metal, every possible solutions which you can find it out. Okay, so while installing the Kubernetes cluster, okay, many things you have to bring into your consideration, and one of the most important thing which you have to consider is which is the cluster networking you are going to use it. What are the parameters, the scalability requirement you have it? What are the high availability requirement you have it? What kind of disaster recovery mechanism you want it? So all these things you are going to have it in place into the consideration before you decide which installation platform you want. So if you want to install desktop, or you want to install through manual way using Kubernetes, or you want to install through the from scratch, that is called hardware or cloud solution, which we are using for this program, such as EKS or GKE or EKS and many things. It's up to you. All the platform you get is something similar environment. Okay, so desktop is recommended. Let me tell you, Minikube. Minikube is one of the things for the desktop. Kubernetes manual way in the virtual machines. If you want to set up from scratch each and everything manually, if you want to do smallest to smallest thing, so you can understand in and out about that Kubernetes, then hardware. If you look at the slide, bottom link, which belongs to the hardware, which will help you to set up from the scratch, or cloud scenario, which is powered by cloud platform like AWS, Azure, and Google Cloud. So it's you decide how you want to set it up. For me, if you ask me where you should start with, so you can start with Minikube. Minikube again is a simplest and smallest form of Kubernetes cluster, which you can get up and running in your desktop, in your laptop. More simplistic, or if you want to go for it, GK, other one, AWS provide like EKS, COPS and stuff like that, and manual installations like a Kubernetes. Again, simplest to the advanced, whichever way you feel alike. Okay, so we are using the AWS provider, which is the EKS, but again, I'll discuss a little bit about the Minikube. No demo will be given, but I'll provide you the sufficient document to get started. Now, Minikube. What is the Minikube? Minikube is a VM, virtual machine, that's all. Yes, Minikube VM you can run on the laptop, on a Mac. Minikube VM you can run on the Windows. Minikube VM you can run on the Linux, because VM you can run anywhere. You can run Minikube anywhere because it's a VM. VM you can run on anywhere provided you have a hypervisor like a VirtualBox, which is the default supported. Okay, so what you have in the Minikube? So you have a node, you have a master, you have a container runtime. Okay, you have all this thing. So these are some of the installation requirements which you have. You just need to know minimum installation requirement. What are the operating systems supported? Linux, Ubuntu, CentOS, 2 CPU, 2 GB RAM, minimum swap should be disabled. Container runtime should be there, like a Docker and all. Networking should be there. So these are the system requirements for the setting up the Kubernetes cluster. Now, what are the ports should be available? So yes, you look at these slides, which you have a little bit of the idea about what you can should be open, what should not be open. So if you look at this here, in the master you have API server which runs on 6443 port TCP used by all. etc again is used by the API. You know that we have discussed a lot on that. Scheduler which needs to be open with 1051. Self, it's used by self. Controller manager, okay, it's on 10252 self. Again, kubelet runs on the 10250 control panel, and then kubelet again. Node port can be anything. again. So all these thing ports should be should be taken into the consideration when you install set up the Kubernetes manual ways and stuff like that. Okay, so now if you see here, git instructions you can get on the official handle, which is on the github.com/kubernetes. That's where you get it. Kubernetes installations is supported by yum and apt both. Linux distribution repository, you get it. So what you want to do, building your cluster. So install Kubernetes, create your clusters, configure pod networking, and join nodes to your cluster. These are the 4 things which you have to do to get started. That's all. So if you want to set up your cluster, install Kubernetes, create a cluster, configure pod networking, join nodes to your clusters, and these are the 4 things. Let me tell you, these are the thing manual which I'm talking about. Yes, in EKS we will not do any of these things. And after that, these are the required packages which you need: Kubelet, Kubedium, kubectl, Docker. These are the required packages. Now, Kubelet, you understand where it will be, right? Kubelet, correct?
Yeah.
Kubedium is a manual way to set up a Kubernetes cluster. kubectl is the way human needs this one to connect to the API server. So these are the things which is the manual installation. So I would like to skip it. Okay, not getting into the manual installation too much because we are not using anyways, but we'll get into the rest of the discussion. So I hope we have discussed the required information in order to set up a Kubernetes cluster. As part of the discussion, as part of the demo and lab, I'll be using the EKS, and again EKS we have so much of discussion which is pending, but because we have spent a lot of time understanding the architecture component here and there, I'm not going to spend more time on the discussion. Rather than I'm going to utilize the remaining time for the demo and lab. Okay, so do you have any questions before me getting started with the demo?
Just one last question. So if at all they're going to provide as a cloud team, they're going to provide as an EC2, then it is an legacy way that we go install the Docker, then Kubernetes on top of that, like that, or what is that? If we are going to get an EC2, only
So
EC2
if you
machine,
see,
Linux EC2.
if you go for the EC2, that's a manual installation. Then in that case, you have to use the Kubedium or POPs. Okay, so let me put it some notes here. Let me first store this notes. So now in the Docker session, you got the notes in the Docker directory. But because we check Kubernetes, you get the notes in the Kubernetes directory. So if you look at this here, 2019, I am setting up is online. It is a corporate. This is Deloitte. And the month is August 2019. This is your file name, which will be used next 3 days for everything. So now first question is how to install Kubernetes cluster. I just said there's so many ways, but let me tell you, put it this way, hard way. So if you go in the Kubernetes hard way, so there's one guy who has spent a lot of time, and to create one of the best documents ever to set up Kubernetes hard way, and we all appreciate his hard work. And the documents which you can find it in on this GitHub URL, this is the one. So yes, if you want to set up a hard way, you can follow this one. If you want to set up a manual way, then you can use 2 utility. One is Kubedium, another one is COPS. Both are recommended and for the production level. Kubedium, this is the documentations. Okay, here you can go through this. And COPS, This is also very powerful utility which you use. Ops. And here. Now I am using cloud-based and desktop-based, which I'm recommending if you want to try it out. Minikube. There's so many solutions out there. It's up to you. You have to find out which one is your preference one. So Minikube. This is the one. So Minikube is a VM, virtual machines, which you can go for that. But right now we are using PaaS on cloud, and that is we will use EKS. Okay, in EKS is a platform as a service, and if you know that what is the definition of the platform service, that means you don't have to worry anything about the cluster. Someone else will manage your cluster, their security, availability, everything will be managed by someone else. Who someone else? AWS. And then you just need to have a desire. You need to just write a declare. You need to just have a desire, declare it in YAML, send it to the Kubernetes master. Rest of the things will be done automatically. So this is what we are using for our program. So are you clear so far? Any questions? Any doubts? Any questions? Any doubts?
No, sir.
Okay, guys. So now I am going to explain you this one only, so you understand well about the things. So now, can you be a little bit more interactive, because I just need information from you. In Kubernetes, you have a master, you have a worker, a node, and you have workstation. Okay, 3 things you have. In the master, which is the component which we have? Which component you have?
API.
API server. What else?
Cluster store. Cluster store.
Controller.
Cluster store. What else?
Controller.
Scheduler.
Controller manager.
And scheduler. And scheduler.
Scheduler. Good. Now, the worker nodes.
Kubedium.
Kubelet. What else?
Container manager.
Docker.
Yeah.
What else?
Proxy. And the proxy.
In the workstation, what you need?
kubectl.
kubectl. Wonderful. Guys, we have discussed all this stuff. Now a little bit elaborate. Understand, try to understand, and this concept is applicable for everywhere. Now, kubelet is a package. I told you in the slides also. Docker is a package. kubectl is a package. Now, what is API server? It is an app. Correct? Cluster store is also app powered by etcd. Controller manager is also app. Scheduler is also app. Now, kubeproxy is also app. Think about it. When Kubernetes is having app. So Kubernetes asks you to run your app inside what? Your app. Guys, so Kubernetes asks you to run your app inside what?
Docker interrupt paths.
Guys, app. Remember running
And
app.
the
It's all
Docker
about
package.
they ask you to run app inside a pod, correct? Guys,
Yeah.
remember
Container.
they ask you to run your app inside a pod. Now, pod has what?
Containers,
Containers.
Containers.
Containers
Containers come from where?
Docker
from
images,
Docker
Image.
package.
Image. Docker image, right? Right? An
yes,
image come from where?
Docker file,
Image come from the registry. Remember registry which you have used it. Docker Hub registry, Google registry, ECR registry, and many more. Right? Guys, are you okay with this flow?
yes,
Okay, good.
Yeah.
Now you tell me, app is the something which you develop. Dev team develop, QA team develop, validate and all. How this pod is getting created? How this pod is getting created? Who initiate a pod? Do you remember that? Who initiate the pod? And guys, I need this from you because I have spent almost a day, my time frame discussing about all the building blocks. So the question is very simple. Who initiate a pod?
Scheduler.
No. Remember where the pod is lying?
In working nodes.
Worker nodes.
In the nodes, right?
Worker
In the
nodes.
nodes, what you have
Yes.
which initiate a pod?
Kubelet.
Yes. So pod is coming from the kubelet. Now guys, you tell me, containers. Who create a containers?
Docker.
Yes, Docker. And Docker images come from the registry and all this stuff, and you know very well. So what I'm trying to tell you here, just think about it. Now one more thing I am going to ask you. Let me ask you one thing. How this API server, cluster store, controller manager, scheduler, and kube proxy, how do they communicate with each other? Guys, how do they
API,
communicate with each other?
API server receives the request and stores
But
the
how?
data in the cluster.
What way they communicate with each other?
Localhost
They
network.
communicate through each other through the REST API, right? Remember REST
Yes.
API server, right now? I think you forgot. Let me explain it. Let me
Yes.
remind you. Here, REST API exposes the API REST. That means every component of the Kubernetes cluster talk to the API server, and API server exposes to the API, which is based on the REST API. Correct? Guys, are you with me?
Yes.
Yes. So now, guys, every component, they communicate with each other through the REST API. So can I do one thing? Can I keep it this in one virtual machine, this in one virtual machine, this in one virtual machine, this in one virtual machine? Can I keep it? If you understand the REST API, they communicate through HTTP, right? So can I keep it in the different machines?
Yeah. You can.
Yes, you can keep it. Yes, you can keep it all this thing in the different machine. But can you keep it in one machine also?
Yes.
Yes.
Yes. You got my points. So guys, what I'm trying to tell you here is master Understand, guys? Master is just an illusion. It's just illusion. Master can be all this component which you have running here. It can be running in the 4 different machines, or you can run it in a one machine. It's up to you, because by architecture it is allowing you to run in the different machine or same machine, provided they all communicate with each other through the REST APIs. And REST APIs, you know the architecture, anyone can communicate over the TCP, over the HTTP, right? So now, yes, now one more thing I want to tell you. I've been telling you a lot. In the worker, you have a kubelet, Docker, kubeproxy. Do you remember here? These 4 are app come, and if Kubernetes says you should run your app in the pod, so they should also follow their the instruction for themselves also. If they are suggesting you to run your application in the app, they should run their own application also in the pod. So yes, these are app. These are the app. These are running the pod. Inside the pod has a container. Container come from the images. Image come from the registry. So basically, pod can be created using only initiated by only by the kubelet, and containers also is being created only by the Docker. So basically, guys, what I'm trying to tell you here is, in the master also, you will see kubelet and Docker. Did you understand me what I'm trying to tell you? Guys, did you understand what I'm trying to tell you?
Yes.
And then kubeproxy, which is a pod networking services. So for all this pod, you need a kubeproxy networking services. So yes, kubeproxy also need to be here. So guys, what I'm trying to tell you here is, master has all the 4 component, has a kubelet, has a Docker, has a kubeproxy. Master has all these components, and this one VMs also can act like a one VM cluster. So because to become a master, you need a 4 component, and to become a node, you need these 3 components, and all these component you have in the master, and this is your minikube. I said minikube is one of the VM, and the VM, all this component is pre-installed and pre-configured, and this is called single node cluster for learning purpose. Did you understand what I'm trying to say?
So is it specific to Minikube?
Yes, it is specific to minikube, but let me tell you here, because you want to run in the master server, you want to run all these 4 apps anyways, kubelet, Docker and kubeproxy will be there no matter whether it's a minikube or not. But this is the simplest form of the cluster with one node, one master, same VM, same machine. This is called minikube. Got it? Guys, did you understand this?
Yeah. But if we go to EKS, in that also in the master, do we have is this node components already present?
So in EKS, this entire thing is a managed services. You will not be managing. This is a platform as a service. That means you will not be managing. AWS will manage, but this you will be having a control.
Okay.
Okay, this is a platform as a service, so they will manage. You have to just pay money to them. So HA, security, everything will be high availability of the master will be taken care by them, not by you. But yes, you can set it up manually also. As I said, Kubedium you try here, Kubedium. This is the one. So do you understand what I'm trying to tell you? Any questions, guys? Okay, guys. Now, so this you have to have in your workstation. Okay, this you have to have in your workstation. Now, there is a one package which is called kubectl, which you install in your laptop. kubectl will interact with API server, and from there the API server that story which you know very well. Okay, but there's something which is missing here. I need to talk about it. I'll talk about it in some time. But do you have any questions on this architecture which you have concluded? No. So now the question is how to set up EKS. How EKS works. What is the admin responsibility in EKS? EKS networking, EKS storage, and many more. So guys, all this thing, I need a little bit of the discussion time. So I'm not going to discuss all this thing, because if I discuss, then my whole day will be wasted only in the discussion, no demo and no lab. So now I'm going to set up the EKS and directly using that EKS. Okay, so now these questions I would like to answer tomorrow. Before that, I'm going to set up a EKS. So for that, let's get started. So now I am going to go and follow my notes, which I have already published in this place. At this notes, you can find it, by the way, so many other notes also, like how to set up using QADM, POPs, EKS, Google Cloud, all these things. But right now, EKS, and search this. I have to search here. And this is a document, so you can refer it. So I think this document is written probably 6 to 8 months before, but still I think it will work, and there's no problem. But again, there's some changes which is always happening, so always it's good to also refer EKS cluster setup. This is the official documents what you have. Here it is. This is the one. This document, it has a little bit elaborated stuff which you can get started, and like that. Okay, so guys, any questions apart from that? So before we get started, so now the question is, which region this is supported? So let me tell you, EKS got introduced in the 2 region initially, but now it is supported in the multiple region. Okay, multiple region. So I'm going to start with these 2 documents and to set up EKS. So let's get started. So I'm going to log into AWS. Sign in this document. Sign in to the console. And now if you look at this, so if you see here, I'm in the Mumbai region. Okay, you see here Mumbai region. Now, if you go, recently EKS server setup is supported in the Mumbai region also. But earlier, you were having only 2 regions for the EKS, and that is called North Virginia, US East, and Oregon, US West. But now, since last month, they started supporting Asia Pacific Mumbai region also. So now if you go here and you type compute EKS, here you have it, and ECR you have it here. ECR, which is a registry for images, and EKS for the Kubernetes masters. So this is the something which you have to go through that. Okay. Now you see here, this is the place you can set it up the EKS, ECS clusters. ECS is here, which is out of scope of this discussion. You have Amazon EKS here, and Amazon ECR you have it here. So ECR is useful for the having the images, and EKS for the masters Kubernetes cluster. Now, if you want to see the how it cost, so basically EKS control panel cost $0.2 per hour. So this is the cost which you have to bear with it. Now, what about the nodes? So worker node will be costing you as per the EC2 pricing. Okay. Now here you have a getting started documentations and all stuff like that. So many things which you have get started. So now I'm going to create a cluster. Before creating a cluster, some of the prerequisites I would like you to get comfortable with, which I have in here. So first thing, it's a good practice if you have, create a IAM user, because if you use the root user, then I think you won't get access to the root user. Most of the organization, they'll give you the IAM user. So it's better to create an IAM user and assign all the EKS related access and privileges. So, and then you also should create ID and secret keys and stuff like that. So that's a good practice. So step one, create a one user who should be having all this access. Now you have to create a one IAM role also. That is a role which you are going to use for the communication between the, again, read my lines, communication between the master and the node. Okay, so for this you are going to have a role, and then you are going to have a BPC created. Okay, BPC created, and this step 3 is the one which you have it. And then fourth thing, after that BPC is created, then you also should set up a workstation, and workstation with the kubectl installations and stuff like that. And fifth step, you have to also install the HAPSHO authenticator. So why we need to install HAPSHO authenticator, again we'll discuss in little bit of things little later, but I don't want to get lost and waste my remaining days in the discussion. So that's the reason I'm skipping this discussion. But yes, step 5, you have to have a HAPSHO authenticator for AWS. And here you have to install the AWS client also, 6th step, and then you have to configure AWS. And then finally, once 1 to 7 step is done, then you have to come back and set up EKS cluster and then start working with it. So these are the step 1 to step 10 which you have to do, 11 in fact, step number 11, to get this things working for the EKS cluster. Now step 11, step 12, 13 is just to add the nodes, and 14 step to verify EKS setup. So these are the total overall 1 to 11 steps which you have to do in order to set up a EKS clusters and nodes, IAM and all the related stuff. Okay, am I making any sense here? Am I making any sense here?
Yeah.
Okay, so now these 14 steps I am doing it again. I'm repeating. I'm not explaining each of these things in detail, because I assume some of the things which you know already, like what is IAM user, what is a role, what is a BPC, what is a AWS installation, what is AWS configuration. These things I'm assuming, but few things I'm also skipping, not assuming you will be knowing, because this I need to explain a little bit later and stuff like that. Apart from that, yes, there's an official documentation also, you can read it and get going. Okay, so now this stuff I'm going to follow, but we'll have a one break before that. And after the break, I'm going to set up a EKS cluster that will not take more than 20 minutes. And after that, I'm going to use that cluster. Any questions, any doubts which you have before we started? We get going for the break.
Rajesh, like yesterday, are we going to get the systems to practice this?
Sir, what is said?
Yeah, are we going to get the systems to practice this lab?
There's no system
Like
will be given. We all are using the
Okay.
EKS, which is a cloud service. So I am going to set up a cluster for everyone. Okay, and we all will
Okay.
get the EC2 instance to practice over the EKS, because EKS we don't have any control over there. Getting points? We don't have control rather than knowing it. Okay, so yes, it's a platform as a service, so it's a good thing. But yes, how to perform a desire in a YAML, that I'm going to teach you. I'm going to teach you EKS configuration. I'm going to teach you EKS volumes, networking, and all stuff like that. So one by one.
Okay. Okay, fine.
Any other questions before
So,
we go?
sir, one more I just wanted to ask. When you say that I am user and roles in creation, so it is pertain to some administration role that you'll be setting up, or is a normal admin console role?
No,
Are you
this
going to
is
follow?
only for this IAM and role. It's only for the EKS purpose. Only. This is not at all related to our use cases with any other things. It's only for the EKS setup.
Okay. So if at all, an application is deployed in EKS Docker container, I've already implemented. So when you say that HTTPS, so you're going to show those as well as complete?
Probably I did not get questions, but I think if I complete the demo, your questions will be redefined. So that way we can discuss.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Want to study further? Subscribe to our paid membership to get a deep dive into each and every topic. Do look out for more videos in our playlist and subscribe to our DevOps School channel and hit the bell icon to learn more. Keep learning.